Okay, so I've created a RIP version 1 lab here that I'm going to demonstrate. Here's the requirements. Advertise all the physical and loopback interfaces into the RIP domain. Do not use the network command on R2 to advertise the loopback into the RIP domain. And by default, Cisco's implementation of RIP uses a timer that's not specified by the RFC specification, which I think is 1058. It's from the late 80s. Now, I am in no way advocating or recommending to use RIP in today's networks. It's very legacy. This is just for historical or documentation purposes. But we did use it in a network I worked on back in the 90s. And it was fun. The fourth requirement is to use a basic TCL script to test connectivity for, I should say, the loopbacks on all four routers, because it could get pretty lengthy to add all the IPs in the domain. And this is to prep us because it is something that we will use again later. Here's what we have. We just have 4 basic routers connected with old school Ethernet. And the routers are connected with the major networks. One and 4 is going to be connected about 14. 1 and 2 is going to be connected about 12. 2 and 3 is going to be connected about 23. And 3 and 4 is going to be connected by 34, of course. And we're always going to use the lower number for the second and third octets. The fourth octet is always going to use the router that you're on. At least in my labs. I'm basically already showing you the completed project here at this point. Routing table shows all 4 networks. So the only thing that really needs to be talked about at this point is probably number 2. That's just to try to get you to think out of the box. To not use the network command on R2 to advertise this loopback. That's just trying to get you thinking of another way to do it. Because there are definitely other ways to do it. In this case, I chose to use redistribute connected. So we'll see that under the RIP process. And then you can already see the point of the timer from step 3 is we want to zero out what Cisco calls the hold down timer and leave the others at default. This is the update. This is invalid, hold down, and flush. Now, honestly, I have never seen a situation that would call for the use of the hold down timer. There probably is a use case in the split horizon scenario, but that will be on like a frame relay or a DM VPN network. And frame relay is not really much of a thing as much anymore these days. And then I'll go ahead and explain number 4. Use a basic TCL. It's usually pronounced tickle, I think. Script to test connectivity for the test the. To do that, you just do TCL sh. And then in here, we're basically having a scripting language. Of course, I've already done this over here. So we're going to say for each IP, and then we're going to do a left brace, put the 4 loopback loopbacks in there. Close the left brace and then open another left brace to put in the command we want to do. We want to ping the IP. Now this argument is arbitrary. It could be anything. But since we're pinging IPs, I'm going for it. It's a variable. We can make it anything. Since it was a pinging IPs, I'm going to make it IP to make it pretty straightforward. So I'm just going to paste this in on R2. We're going to see they all work. I'm going to go back to R1 to do the same thing. We're going to see they all work. I'm going to go to R3, do the same thing. And once again, see all my loopbacks are connect throughout the whole small domain. Now, if you had to ping a couple hundred IPs, this would be a much better way than doing it manually, even if you can type fast. Now, I need to talk about number 3 a little bit more. The timer's basic thing needs to be on every router in the domain. They all need to agree. Unless you want to see some odd behavior. You want your domain to, you always want your domain to agree with each other. We'll be back with part 2 at a later time.